Assalamualaikum warahmatullahi wabarakatuh. So right now we will be presenting for group assignment electronic DAE 21303. Our group members consist of three members, which are Deva Balen as a leader and Nur Elisa Muiz binti Muhammad Zaini. Lastly is me, Siti Asiah binti Ismail. Okay, for the first one, I will be presenting about bipolar junction transistor BJT characteristic. So let's take a look at the overview of BJT. So BJT is a solid state current device that can be used to switch a circuit electronically. BJT is an electronic component that is mainly used for amplification and switching purpose. A BJT composed of three terminals called as emitter, base and collector. So this BJT comes with two PN junction. PN junction that exists between emitter and base is called as emitter base junction, and it is forward bias, and the PN junction that exists between collector and base is called as collector base junction, which is reverse bias. Usually, a BJT is made of germanium and silicon, but the recent transistors are made of silicon. BJT comes in two types, which are NPN type transistor and PNP type transistor. Let's take a look at the structures of bipolar junction transistor. So a bipolar junction transistor is formed with three semiconductors region that is doped differently. The three regions are known as base, collector, and emitter. For the base region, it is slightly doped and very thin compared to collector and emitter region. For the collector region, it is moderately doped while the emitter region is heavily doped. This bipolar junction transistor BJT can be either a NPN type or PNP type. In a NPN type of transistor, it consists of two N-type regions, which are the collector and emitter region, separated by a P-type region, which are the base region. But in a PNP type, it consists of two P-type regions, which are the collector and emitter region, separated by a N-type region, which are the base region. For both of the NPN type and PNP type of transistor, the collector and emitter terminals are fixed at the outer layer and base terminal is fixed at the center layer. The two PN junction of a BJT must be correctly biased with a DC voltage to operate properly. Lastly, the two PN junction are base emitter junction, connect the base and emitter region, and base collector junction, connect the base and the collector region. Right now, we will move to the operations of bipolar junction transistor. So the operation of bipolar junction transistor consists of two, which are, for the first one is the operation of NPN type transistor. The second one is the operation of PNP type transistor. Right now, we will take a look at the operation of NPN type transistor. So in normal operation, the base emitter is forward bias and the base collector is reverse bias. Both of the junction must be in that condition for the BJT to operate as an amplifier. So for a NPN transistor, the N-type emitter region has a very high density of free electron. When the base emitter junction is forward biased, it decreases the barrier potential, which is cause the electrons to flow from emitter to base. These constitute the base current IB flows due to the recombination of electron and holes, and the remaining number of electrons will cross the reverse bias collector junction, which will constitute the collector current IC. The base current IB will be very small compared to the emitter current IE and collector current IC. So for this NPN type operation, the majority of charge carriers are electrons. And right now, we will take a look at the second type of transistor of BJT, which is the operation of PNP type transistor. So in normal operation of PNP type transistor, it is still the same as a NPN type transistor. In normal operation, the base emitter of PNP type transistor is forward bias and the base collector is reverse bias. Like what I have said before, the operation of PNP type transistor is the same as NPN type transistor. The only difference is that the majority charge carriers are holes instead of electrons. Only a small part of current flows due to majority carriers. What I want to highlight here is that most of the current flows due to minority charge carriers in a bipolar junction transistor. Hence, the PNP type transistor are called as minority carrier devices. Okay, so right now we will move to the configurations of bipolar junction transistor. Okay, in circuit connection of BJT, four terminals are needed, which are two terminals input and two terminals is for output. So that is why one terminal is used as common terminal for both input and output action. The three configurations of BJT are: the first one is common base configuration, the second one is the common emitter configuration, and the third one is common collector configuration. Among these three configurations, the common base configuration will have voltage gain but no current gain, and the common collector configuration will have current gain but no voltage gain, and the common emitter configuration will have both the current gain and the voltage gain. Okay, right now we will take a look at the first configuration of BJT, which is the common base configuration. In this configuration, base connection is common to both the input signal and the output signal. The input signal is applied between the transistor base and the emitter terminals. So the corresponding output signal is taken from between the base and the collector terminals. The current gain in this configuration is denoted by alpha. So this common base circuit is mainly used in single stage amplifiers such as microphone preamplifier or radio frequency amplifier because of its high frequency response. The next configuration is common collector configuration. Okay, in this configuration, the collector terminals is common through the supply. The input signal is connected directly to the base. The output is taken from the emitter load. This type of configuration is commonly known as a voltage follower or emitter follower. This configuration is mainly used in impedance matching application because of its high input impedance. Okay, so right now let's take a look at the last configuration of BJT, which is the common emitter configuration. So in this configuration, the emitter terminal is used as common terminal for both input and output. The input signal is applied between the base and the emitter. The output is taken from between the collector and the emitter. This configuration is the most commonly used circuit for transistor-based amplifier and represents the normal method of bipolar transistor connection. This common emitter configuration also termed as an inverting amplifier because input signal is out of phase with the output signal. The most importantly, this type of configuration exhibits the ideal power and current required for an amplification purpose. And now we will move to the part of reading transistor datasheet of BJT. So for this datasheet, I have choose one of the model in current market, which is the transistor model 2N3903 from Motorola. So in this datasheet, I will be covered the maximum ratings, the thermal characteristic, and also the electrical characteristic of the transistor model 2N3903 from Motorola. So let's take a look at the maximum ratings of this transistor. So for the collector emitter voltage, the maximum value that the transistor can hold, that the transistor can withstand is 40 volt. That was the maximum value of voltage for the collector emitter. So for the collector base voltage, VCBO, the maximum value of voltage or the maximum value of rating that this transistor can stand is the 60 volt. Okay. For the third one is the emitter base voltage. The symbol is VEBO. The maximum rating is 6.0 volt. The next one we will take a look at for the collector current. Okay, the collector current is the continuous current, IC for the symbol. The maximum rating for the collector current that the transistor can stand is 200 milliamp. So the current is the DC current. Okay, so next one is, let's take a look at the total device dissipation or power dissipation for this model. The maximum power dissipation is 625 milliwatt for this component. So if this device is derated above 25 degrees Celsius, the maximum this transistor will degrading. We will have to degrading the component to 5.0 milliwatt for every degree Celsius. The next one is the total device dissipation for TC equal to 25 degrees Celsius. The first one is for TA and the second one is TC. So the total power dissipation is 1.5 watts. So if this component is derated above 25 degrees Celsius, we will have to degrade the power dissipation 12 milliwatt for every degree Celsius. And for the operating and storage junction, or generally is the temperature range of this transistor, T junction or T storage is from the maximum rating of the temperature range is from -55 up to 150 degrees Celsius. So in this range, the transistor still can work properly. Okay, right now we will move to the thermal characteristic of this 2N3903 model of transistor from Motorola. So the thermal characteristic, the first one is the thermal resistance junction to ambient. The symbol is R0 JA, junction to ambience. The maximum thermal resistance for this transistor is 200 degrees Celsius per watt. And the second one is the thermal resistance junction to case. So the symbol is R0JC. The maximum resistance is 83.3 degrees Celsius per watt. And we will move to the last one, is the electrical characteristic. For the TA equal to 25 degrees Celsius unless otherwise is noted. So we will take a look at the off characteristic. So the off characteristic, the first one is the collector emitter breakdown voltage. Collector emitter breakdown voltage. Okay, the symbol is VBR, collector emitter. O here means that the base region is open. Okay, so minimum voltage for this collector emitter breakdown is 40 volt. The next one is the collector base breakdown voltage, VBR breakdown voltage for collector base, and the emitter is open. Minimum breakdown voltage for the collector base is 60 volt. The third one is the emitter base breakdown voltage. For the emitter base breakdown voltage, the symbol is breakdown voltage EBO, which means the emitter base collector open. So minimum breakdown voltage for emitter base breakdown voltage. Minimum breakdown voltage for this emitter base is 6.0 volt. And the second last is the base cut off current. Okay, for VCE equal to 30 volt and the VEB is equal to 3.0 volt. Okay, the symbol is IBI, which are the base cut off current. Okay, there is no minimum range, and for the maximum value cut off current for base is 50 nanoampere DC. Okay, and the last but not least, the collector cut off current. For the collector cut off current, the symbol ICEX. Okay, the maximum cut off current for collector is 50 nanoampere DC. That's all about reading the datasheet for this bipolar junction transistor for model 2N3903 from Motorola. Okay, that's all from me.
Hi, Assalamualaikum. My name is Nur Elisamis binti Muhammad Zaini with matrix number AA190210. So today I'll be presenting about the JEPET characteristic. So let's move to another slide. So let's go to the introduction and overview of JFET. So introduction of JFET, or known as junction field effect transistor. So basically JFET is one of the types of FET transistor, which is it is the simplest form of FET transistor and used as electronically controlled switches, voltage control resistor, and amplifier. So it is available either in N channel or P channel, and it is a unipolar transistor, but it has a similar characteristic of its bipolar cousin. So it is an essential component for a precision level voltage control resistor, or as a switch, or even make an amplifier using JFET. And it is also an energy efficient, which provides low power consumption and fairly low power dissipation, thus improving the overall efficiency of the circuit. It also provides very high input impedance, which is a major advantage over BJT. So as you can see, here's the structure of the JFET transistor, and it can be classified into two types, which is N-channel JFET. This one is the N-channel, and this one is the P-channel JFET. So in N-channel JFET, the channel is doped with the donor impurities due to the current passing through the channel is negative, which is electrons. But in p-channel JFETs, the channel is doped with the acceptor impurities due to the holes, which is the current flowing through this channel is positive. So the N-channel JFET has more current conduction than P-channel JFET because the mobility of electron is greater than the mobility of holes. So the N-channel JFET are widely used more than P-channel JFET. So the small voltage at the gate terminals, so you can see here, this is the gate. It controls the current flow in the channel between drain and source in JFET. As we know, in BJT, the emitter and collector terminals are connected using a PN junction. But in JFET, it is the drain and the source terminals, which is it connected with the channel. So the small voltage applied at the gate terminal controls the current flow in the channel between the drain and source of the JFET. So this gate voltage is negative in N-channel JFET and it is positive in P-channel JFET. To compare with BJT, BJT here is the collector C, the drain as the collector, and source as the emitter. And the gate is base. So that's the difference between the structure of BJT and JFET. So this is the common source configuration. So in common source configuration, it is similar to the common emitter. The input is applied to the gate and its output is taken from the drain as shown. So this is the most common mode of operation of the FET due to its high input impedance and good voltage amplification, and as such common source amplifiers are widely used. So the common source mode of FET connection is generally used audio frequency amplifiers and in high input impedance preamps and stages. So being an amplifying circuit, the output signal is 180-degree out of phase with the input. So let's move to the configuration type of JFET. And this is the common gate configuration. So in common gate configuration, it is similar to the common base in BJT. The input is applied to the source and its output is taken from the drain with the gate connected directly to the ground as shown in the picture. So the high input impedance feature of the previous connection is lost in this configuration as the common gate has a low input impedance but it has a high output impedance. So this type of FET configuration can be used in high frequency circuits or in impedance matching circuits where a low input impedance needs to be matched to the high output impedance. So the output is in phase with the input. And this is the last configuration, which is a common drain configuration. So in the common drain configuration, it is similar to the common collector in BJT. So the input is applied to the gate and its output is taken from the source. So the common drain or source follower configuration has a high input impedance and a low output impedance and near unity voltage gain. So therefore used in buffer amplifiers. So the voltage gain of the source followers configuration is less than unity and the output signal is in phase 0 degree with the input signal. So this type of configuration is referred to as a common drain because there is no signal available at the drain connection and the voltage present just provide a bias. So the output is in the phase with the input. So here's the operation of the JAPAT transistor. The left one is the saturation mode and the right one is the pinch off mode. So generally, one of the best example to understand the working of JAPAT is to imagine the garden hose pipe. So suppose a garden hose pipe is providing a water flow through it, right? So if we squeeze the hose, the water will be less, and at certain point, if we squeeze it completely, there will be no water flow through it. So JAPAT works exactly in that way. So if we interchange the hose with the JAPAT and the water flow with a current, and then construct the current carrying channel, we could control the current flow through it. So when there is no voltage across gate and source, the channel becomes a smooth path which is wide open for electron to flow. But the reverse thing happens when a voltage is applied between gate and source in reverse polarity. That makes the PN junction reverse bias and makes the channel narrower by increasing the depletion layer and could put the JAPAT in a cut-off or pinch-off region. So in the picture above, we can see the saturation mode and pinch-off mode, and we will be able to understand the depletion layer become wider. So here's the saturation mode, this one, and here's the pinch-off mode. So as we can see, we can uh, understand that the depletion layer, here's the depletion layer, the red one, this one, the red one, and then this one. This is the depletion layer. Okay, and the current flow become less. So here's where the current flow through it. And in pinch off, the way for the current flow is become narrow compared to the saturation mode.
Hi, hello, and my name is Deo Balan, and I will be explaining about our electronic assignment about BJT and JFET. So I'll be explaining about the comparisons of BJT and JFET. So first thing, carrier. The carrier for BJT is bipolar, while the carrier for JFET is unipolar. And the device type for BJT is a current control device, while for JFET it's a voltage control device. The input impedance in BJT is low, and the input impedance in JFET is high. BJT has higher gain, and JFET has low medium gain. So the power consumption of BJT, it consumes more power, while JFET consumes less power. So apart from that, according to noise level, BJT's noise level is high, while JFET is low. The thermal stability of BJT is low, while JFET is high. The size of BJT is large, while JFET is small. Application reference of BJT, low current application, and the JFET application is low voltage application. And this is an example of amplifier circuit of BJT. As you can see, from the source sound received from the microphone to the speaker. So when the sound is received, it amplifies the speaker. So common emitter amplifies drives speaker with audio frequency signal. Another example is that since the microphone may produce voltages exceeding the forward voltage drop, of the base emitter PN diode junction. A resistor must be placed in series with the microphone. So you can see as the figure below, this is how the implementation of BJT is. Now, this is the example of amplifier of JFET. First one is a cascode amplifier circuit. So you can see here, this is the cascode amplifier circuit for JFET. And the second one is a multiplexer. This is an analog multiplexer. So IB equals to IC over beta, which equals to 4.58 milliampere over 100, equals to 45.8 microamperes. So that's for this question. Okay, for the next question, it's a complete common emitter circuit. For this question, we will find R2, R1, our IG and RG and R1, as you can see as in the calculation above. So we will just follow the formula as given to solve the equations. Okay, this is a sample question for common source amplifier circuit JFET. So the question asks, determine ID and VGS for the JFET with the voltage divider bias in the figure shown. Given that for this particular JFET, the parameter values such as VD is almost equals to 7 volt. So for ID, to find ID, VDD minus VD over RD. So our VDD is 12 volt and our VD is 7 volt. So RD is 3.3 kilo ohm. So our ID will be 1.52 milliampere. For VS, ID RS. So 1.52 milliampere times by 2.2 milliampere equals to 3.34 volt. To find VGS, so we have to find VG first. So VG equals to R2 over R1 plus R2 times VDD. So 1.0 mega ohm. I'm sorry, it's mega ohm over 7.8 mega ohm times by 12 volt equals to 1.54 volt. So VGS equals to VG minus VS equals to, so 1.4 volt minus by 3.3 volt. So VGS is negative 1.8. So that's a sample question and solution for JFET. And these are the reference links. And that's all. Thank you.